This is lesson 5.5 of accelerated geometry, and it talks about the properties of special parallelograms. The first parallelogram that we're going to talk about is a rhombus. So here we have a rhombus is a parallelogram with 4 congruent sides. So here is a sample of a rhombus. All 4 sides are equal. Now I'm going to go over to Sketchpad, and I'm going to talk about this rhombus. Here is a figure that has all 4 sides equal. And if you take out your conjecture list, we're going to start with conjecture number 46, the diagonals of a rhombus. Okay, so now if I'm going to talk about the diagonals of a rhombus, here they are, here and here, and the angle HIG, whoops, is 90 degrees where those two meet. So they are perpendicular to each other. And I'll move that aside, and then I'll say from H to I is 4.05, from F to I is 4.05. So they are bisected, cut in half. This diagonal here is bisected, cut in half to form 2 equal parts. And if I go from E to I and from G to I can see that that diagonal, EG, is also bisected by the other diagonal. So therefore, conjecture number 46 says the diagonals of a rhombus are perpendicular and they bisect each other. Okay, I'll move that aside. So these measurements, I'll just move them on the side here, out of our way. Okay, now the next one says, the diagonals of a rhombus, something the angles of a rhombus. So EHF is up here, and GHF is over here. H, G, and E, so H, G, and E is here. F, G, and E would be here. Okay, so now the diagonals of a rhombus bisect the angles of a rhombus. So here is a diagonal, and you can see that it took this angle and this angle to be 33 degrees, so therefore it bisected that angle EHG. Okay, and then also over here, if I look at this diagonal, and then I look at the 2 parts of angle HGF, angle HGF was bisected also by this diagonal. So the diagonals of a rhombus bisect the angles of a rhombus, all the angles of a rhombus. Okay, now back to the definition, our next definition, a rectangle. A rectangle is a parallelogram with 4 equal angles, 4 congruent angles, 4 90-degree angles. So here is a picture of a rectangle. And now if I go back to Sketchpad and go to my rectangle, the first conjecture for the rectangle says the diagonals of a rectangle are. Okay, if I look at the diagonals, what are they? NQ and RP. So if I look at NQ and I look at RP or PR, they are equal to each other. Okay, then I have these parts here. From C to N and from C to Q are both 2.62. And from C to P and from C to R are both also 2.62. So the conjecture number 48, the diagonals of a rectangle are congruent and they bisect each other into 4 equal parts. And then our last figure that we're going to talk about is a square. And the square is a parallelogram with 4 equal sides and 4 equal angles. So here is a picture of one. 4 equal sides and 4 equal angles that are all 90 degrees. And the conjecture that we are going to deal with now is conjecture number 49. So conjecture number 49 starts with looking at a square. And I'm first going to look at the diagonals, CA and DB. So here they are, AC and BD. So they just named them in the other order, are both 5.56. If I move it, they still stay the same. So the diagonals of a square are equal to each other. And angle AEB is 90 degrees, which means that the diagonals are also perpendicular to each other. Whoops. And A to E is 2.71, B to E is 2.71, C to E is 2.71, and D to E is 2.71. So therefore, the diagonals of a square also bisect each other. So there's three parts to the diagonals of a square. The diagonals of a square, conjecture 49, are congruent, and they are perpendicular, and they bisect each other. So now if I go back to the class notes for the day, I have all of these conjectures listed as the last slide. So you can look at conjecture 46, 47, 48, and 49. Make sure you put them on your conjecture list, and also draw appropriate sketches for each of them so that you can look at the sketch and know what the conjecture is about, or look at the conjecture and know what the picture is about.